So we're going through the 2-axis lathe functionality today. Some of the basics, like how to create the wireframe that I have for my lathe part here, and also some of the advanced settings that we've added into our newer versions as well. So in the wireframe, if I wanted to create it like this, I'm just going to blank out the cam portion, the stock and the turning job there for now. And let's say I want to create my wireframe like this. I can just go to Create 2D, and I can start drawing my lines and arcs here. Now you can see when I'm sketching down at the bottom left corner here where my cursor is. I'm sketching in X and Z coordinates. Now, normally, it's set to X and Y coordinates that you can see. But here at the top, under the Home tab, I have this turning mode option. So if I'm more familiar with sketching from Z0 right here and X0 right here for lathe coordinates, I just click on Home and click on Turning Mode. And that gives me my Z and X coordinates down at the bottom. And when I'm in any of my sketching functions, I'm sketching in Z and X coordinates now. So I can go, let's say Z0, and I'm going to go up to X1 for my start point. And my end point is going to be Z -2 X1. So I'm creating a straight line just going across like that, clicking OK to finalize the sketch there. And I could also click point to point here and just start sketching like this. So very basic options for creating lines. Creating arcs is also in Z and X coordinates. And if I want to create an arc from a corner here, I can go into Create 2D, and we have our fillet and chamfer options up at the top. So I can easily create a 1/4-inch radius on the corner here by just clicking on the two lines to create a radius on the corner for a fillet. Just some basic options there to create your drawing in lathe. It doesn't get much more difficult than that because most of our other creation options here are going to be for the milling functionality. Now, let's say I import a 3D model and I need to create my wireframe. Oh, let's get rid of this one for now. There we go. And let's say I need to create the wireframe from my 3D model here that I import. First, I can import the model up at the top by going to File, Open. And I can open any type of file here, generic file types from other people or customers as DXF or DWG drawings. And we also have 3D models. You can open as IGES, STEP, STL models, SolidWorks part files, Parasolids, RhinoCAD files. All of the generic file types you can open from CAD software programs. You can open, or you can save and export as a generic file type like a STEP file, and then be able to open it into BobCAD like this. But in our lathe functionality, we need to use wireframe to create wireframe here to use as the geometry that we're turning from. So to do that, in the Create 2D, we have this function over here on the right-hand side called Spun Profile. So I click that, I highlight my geometry of the 3D model here, the surfaces, and click OK. And oops, I wanted to put it on a different layer here. So I go to my layers page over on the right-hand side. I can right-click anywhere in this window and add a new layer so that the wireframe is going to be separate from my CAD layer that the 3D model is on. And I can blank or show any of the layers with this eyeball icon next to it. And I can create the wireframe on layer 5 here by making it active with this green check mark, checking the box here. All right, so I'm going to try that again. I'm going to window select the surfaces, and I'm going to click OK. I'm going to hide the CAD layer that the 3D model is on so that I can see the wireframe that it created. It basically creates flat wireframe from a 3D model, a cylindrical shape like this, to give me my spun profile. And it's along the Z-axis because it's going around the cylinder, and the cylinder is going around the z-axis in my lathe coordinates here. All right, let me know if you guys have any questions. I'm so used to doing training sessions that I'm waiting for a response back to see what you guys have any questions on. But yeah, if you guys have any questions, let me know in the comment section, and we'll be going into the CAM portion from here, since I have my CAD geometry of the wireframe on this layer 5. And let's see. Yeah, I'm trying to think of anything else we could go over yet in CAD. Just creating the 3D, importing the 3D model, creating the wireframe from the 3D model, and then doing our turning job from here. So up at the top, I go to CAM, and I go to a new job. We go to turning, and we select our machine. So BC2X mill stands for BobCAD 2-axis lathe right here. And we have many other machines built into the software program by default. If there's a machine that you don't have in this list, you can go to our support page, bobcadsupport.com, and there is a page there to download a post processor for your specific machine. So there's an extensive list of machines in there that you can download for. If you don't see your machine in there, then we could do what's called a post request. You can request a new post processor for your machine specifically, which entails sending us a sample program that works correctly on your machine, a list of G&M codes and their functions, and any CAN cycles that you may be using, G71, G72 CAN cycles, and things like that. Bob asked, if there was a boss, would it show on the spun function? Well, yes and no, I would say. If you did an extrude boss, you want to make sure that you're making it as a cylindrical part. If it's something like this, I couldn't use extrude boss with. I would use what's called the revolve function to create the cylindrical shape that would be the same exact one as my same exact kind of shape as my 3D model that I imported. Now you can see it's only half of the solid model because the rotation is 180 over here, so I just change it to 360. So that's how you could create your cylindrical part for turning, and then yes, you could use the spun profile function to get the wireframe from there. Good question though. All right, so we've got our wireframe. We sort of started on the turning job, and we'll kind of go through there. Again, I go to the top and I go to CAM. I go to a new job, select turning, select my machine, which I'm selecting BC2X lathe, and that is a Fanuc-based G-code output for this machine. And then we go to our stock wizard. We can select our workpiece. That would be our 3D model. So I'm going to my layers. I'm turning on the CAD layer so I can select my solid model here. I'm just clicking on the solid and then going to my next page for creating my stock that I'm starting with, and then setting up my machine setup, which is always going to be at this CAD origin location in the turning functionality. So I select my workpiece, go to my next page. I select my stock, or define my stock here. You can see there's only two options in turning. We have cylinder and we have revolve. Revolve is just like what I did under Create 3D and revolve under CAD. I could go here to revolve and I can select my geometry here and then hit calculate stock. There's the stock that I may be starting with. So maybe if we're working off of a casting or something like that, I can select my stock and define it exactly to what I'm starting with. That way we're going to get rid of any air cutting. But I'm starting from a blank piece of cylindrical stock, so I'm going back to cylinder. I'm going to type in my stock diameter. Let's start with 4 inches. And then my internal diameter, I'm going to leave at 0, because let's say there's no hole through the center yet. I'm going to drill that hole later on. Length, let's give it a little bit more length on the back end so we can do a cutoff operation. So let's do 6 inches. And also, I was going to mention this later on, but it's good to mention this right at the beginning. For my stock origin, this option at the bottom, people tend to overlook this because they think I'm just going to do a facing operation later on. But when you do a facing operation and the part is lined up directly on the stock here, BobCAD later on, when you do a when you do a facing operation, it's going to think, okay, well, there's no stock remaining to face off, so it wouldn't give you any toolpath. So this is a good option to be able to add how much stock you want to shift over, so that you can do a facing operation with, let's go with 50 thou for the stock on the front face to face off. All right, perfect. So I'm going to click OK. And then you can see the turning job that I just created right here. I'm going to right click on Machine Setup 1. And here's where all of our turning operations are. We have lathe end face for a facing operation, lathe turning so that we can turn the outer diameter of the stock, or we can turn the ID of the stock as well on this one. Lathe groove for a groove operation like we'll see that we're going to do right here. Lathe hole for drilling the center hole right here. Lathe tap hole. Lathe thread, cutoff, and stock handling that we can support for a bar feeder. All right, so let's start with lathe end face. Select my geometry. I'm going to just select this line for the facing operation here and click OK. Next page, we can tell the software either region 1, which I'm starting from the top going down, or region 2 if I'm starting from the bottom going up. And here's where I can start from stock, or if you wanted to, you could just type in the number here with custom and type in how much stock you wanted to do for a facing operation. Next page, up at the top, I can do my default strategies. End face rough would be just a roughing operation. End face rough and finish would do a roughing operation and then come back with a finish pass. That's usually what I have set up here. Next page, separate moves or in can cycles. For facing, I normally have it as separate moves, but we can take a look at can cycles for the turning operation on the OD. Next page, we have our tool, and we can output an RPM or constant surface speed down at the bottom right here. And we can also go to the top and change our tool insert and our tool holder here up at the top by clicking on Tool Crib. And changing the tool up here, we have different categories: rough, finish, groove, boring bars. I'm going to leave it under the rough category. And then I can sort the different tools by the label, sort by the tool number. And I can modify one of these tools here. So I'm modifying the tool insert shape. I can select the different parameters right here, or I can select a custom shape. Now, with this one, we're not... I think we went and did the custom shape option in our last webinar on milling tools, but for turning tools, we could take a look at how to create the custom shape of the tool insert and also the custom shape of the tool holder. So let's go over that topic real quick, and then we can go through the rest of the options for the roughing and the finish pass here. So to do that, first I have to either import the tools from the machining cloud. If you have machining cloud and you want to save any of those files as an XML file, you can save it and then import it into the tool library. Or you can just draw up the shape yourself. So if I go into a new file, I'm going to just draw a basic rectangle here, just to make things easy on myself. I could make the corner, let's do the corner radius too. Let's go to fillet. And I know this isn't realistic at all for the tool insert, 2 inches by 2 inches and a 1/4 inch radius here. But you get the idea of the custom shape that you can create for your tool insert. And the only other thing that you have to define is the theoretical tooltip. So I'm just going to create a point for that. Up at the top, I'm clicking on point, and I'm just going to create a point at x0, y0 there for my theoretical tooltip. Then I can go to the top, and I can go to CAM. I can go to New Job. I'm sorry, not New Job. I'm just going right into the tool library to define this tool. So under CAM, I go to Tool Library. I go to the Lathe category here and go to Rough. I can add a tool. I can name it. I am in the way now, so you can't see the tool insert. So let me move myself here. There we go. All right, so now you can see the tool shape. It'll change based on if I change the shape here, if it's a CNMG tool and the corner radius and things like that. I'm defining it based on the custom shape I created. So instead of system shape, I'm clicking on custom shape. And then I'm clicking on assign tool insert. And then here I'm just window selecting. It picks up the 4 lines and the arc of the radius here. And then the point for my theoretical tooltip. I click OK. And there is the giant tool insert. And you can see it down at the bottom here, related to the tool holder. Now you can go into Edit Tool Holder, and you can select a certain shape for your tool holder predefined. You can type in the numbers here, or you can click on Pick Geometry, and then you can draw up your tool holder just like we drew up the tool insert here in the CAD geometry and define it that way. All right, perfect. So Bob was asking, can you rough the face cutting in the Z first, leaving 10 thou, then finish cutting in the X direction for the last cut? That would be in 2 separate options there. You would have to do, yeah, so you can see here under the turning, facing, under that feature page, we only have the option for front face, so it's only going to go up and down. If you wanted to do cutting in the Z direction first, you would have to do a turning operation first, and then you would go in and do the facing operation as a finish pass. But we could take a look at that, those different options in the turning after this. So we've got from stock, for facing, we've got rough and finish, separate moves, and we're back to our tool page. All right, so I'm just going to leave it as our default tool here, and we can set it as constant surface speed. Next page, we have a standard cut pattern or offset. Not really going to do much for a facing operation here, but when we're turning the OD, we can offset from the geometry for each pass. Standard would be for sorting, and then we could also do a zigzag cut pattern up and down. And then we have system comp. So we can turn on system comp for the tool, and we can also turn on collision detection. You can see if I don't have collision detection, the tool holder might run into some areas there. So I always have collision detection turned on, and you also have machine comp here for G41 or G42. Next page, we have our settings for our depth of cut. We have our finish allowance, so I'm leaving 10 thou on the sidewalls and on the floors. For this, it'd just be the sidewalls for facing. I'm leaving 10 thou for a finish pass to clean up. Next page, rapids, where I'm going to rapid from, where we'll rapid back after the operation. Our lead in and our lead out page. Advanced feed rates, where I'm able to If I'm not able to set a rapid rate at the controller, I can set the rapid rate here by changing the rapid moves to feed moves. So whatever a rapid move would have been in the G code, it'll change to a feed move, and I could set the feed rate right here. And then we can also manually change our feed rate for the lead in and the lead out. So maybe if I want it a little bit slower, I can ramp up the feed rate into the cut. I can set it up here. Then our last page for every turning operation is going to be MDI. That stands for manual direct input. So if I wanted to add any G code before or after the operation, I can do that here. We'll do this as an example. I just highlight before tool change. What I normally do is I highlight raw text here so that I can type in whatever I want. And then down at the bottom, I click on command and I can type in anything I want here. So if I want an M01 command before the operation, I can do that here. Or let's say I want it to be a comment, and I can click on comment over here, and it will add parentheses before and after every line of text I type in here. So I'm just going to type in test comment so that we can see that in the G code once it's done. Then our next page, we're getting to the finish pass, and we're using the same tool, tool number 1, for the finish pass. We also have the spindle direction down at the bottom and also coolant type options. Next page, we're turning on collision detection. For a finish pass, we have a continuous finish pass. If we're doing the OD like this, we can alternate back and forth. We can face the vertical only or turn the diameter only. All right, and then our next page, we're leaving an allowance of 0 because this is a finish pass. Then same options as before. For every turning operation from here on out, we have our rapids, our leads, our advanced feed rates, and our MDI. And I'll hit compute. So once that is done computing, we'll go through the turning operations on the OD. So we're really just doing 2 passes. The first one is just our depth of cut of 50 thou, leaving 10 thou here for the finish pass right here. If I want to see them play out, I could go over to my cam tree and I can backplot them before I go into the full simulation. So doing that, I'm just going to right click on either the rough or the basic finish operation here. I right click and I go to backplot. And then from there I can see the tool and I can step through and I can see every position of the tool as it goes across and come out. Perfect. So we've got our facing operation, and then we've got turning on the OD we'll do next. So I'm going to right click on machine setup 1, and the next one down I'm going to lathe turning. Select geometry. I could click on this line, hold shift and click on the end of the chain here. So hold shift and click to chain select all of it. I could also maybe window select lines and arcs individually there, but this is an easy way of selecting everything I need. My next page, I'm turning on the OD. So here's your question, Bob, of doing the Z direction. I would do this operation first, just a roughing operation on the face, and then I would come back to do just the facing in up and down in X. We also have turning on the ID, if we're using a boring bar to do a turning operation on the ID of the part. Front face and then back face as well. So I'm going to select OD and I'm going to select from stock. I'm turning everything that I have remaining from my stock here. Next page, we'll do a rough and a finish again. We'll go to the next page where we have separate moves. Maybe let's take a look at the G code in separate moves, and then we can take a look at it in CAN cycles. We could go over that topic today as well. We'll use the same tool, tool number 1 here. Turn on collision detection. Depth of cut, again, we'll do 50 thou. We'll leave 10 thou for the finish pass. Rapids, leads, advanced feed rates, and MDI. Then for our finish pass, we'll use tool number 1 for the finish pass, same tool here. Turn on collision detection. And then next page, 0 for our finish allowance, then our rapids, leads, advanced feed rates, and MDI. And we'll hit compute from there. So let's take a look at a quick simulation of it. Take a look at the G code, and then we'll go over some other topics after that, like the groove operation. We'll do the drilling operation, and answer any questions that you may have in the turning operations here. So up at the top, I'm going to click on Start Simulation. You can take a look at the front face here, so we can look at it from the side like this and hit Run. Something's going on weird with the simulation. You can take a look at the cycle time up at the top. It's saying 282, and that's an hour, so something in the feed rates are wrong there. Not sure. If I go to each tool page, I'll see what's going on. Let's do, I don't know, let's do RPM maybe? And if I change just the feed rates, technically I don't have to recompute it, so I don't have to waste time computing it like this. I can just hit finish because I haven't changed any of the toolpath. So if I go to each tool page, I don't know what's going on. Maybe something in the constant surface speed. Let's take a look at the simulation now that I changed it to the basic feed rate there. Well, we can also change it from time mode to NC mode. It'll tell us how many lines of code. Right here it's saying 300 lines of code, and length mode will tell us the tool travel, about 189 inches of tool travel for the quick facing and roughing and finish operation here. So I'll hit restart, slow down the simulation run speed, and hit run. Speed it up just a little bit more there. So here's our roughing operation. And then first topic I'm going to go over is we can see the tool travel here going across with the roughing operation for each pass. Yes, it will come up and out of the stock and then move across every time. But let's say we're running across the stock long ways like this, and there's a lot of built-up material at the tool. Well, we have an option now in our newer versions of how to limit that. If I close out of simulation, I right-click on the lathe turning operation and edit that. Under the parameters for every page in turning, we have this chip break option down at the bottom now. So I click on the checkbox here and click on chip break. And here we have a few different options on how we want to retract the tool in between long cuts like that across the stock. We have the length of cut. Let's do a 1/2 inch here. And then we also have our retract distance of 50 thou. I'll click OK and hit compute, and we'll see the toolpath here. We'll take a look at it in the back plot of roughing. Here's the tool. It's going to come down. It's going to run across a 1/2 inch. It's going to retract 50 thou and then come back where it left off and then go a 1/2 inch and keep going across like that. So that's a great way of being able to retract the tool so that the material built up will be removed if we're going along a very long piece of stock there. Our other chip break options include time. So every few seconds, I don't know, let's go 5 seconds maybe. I haven't really messed with the second interval very much yet. But you can see based on the feed rate, this is going to be 5 seconds across, and then after 5 seconds, it'll retract 50 thou. Come back 5 seconds, retract like that. And our other option is length of chip. So based on the OD of the stock that I'm turning, it'll calculate no more than 12.5 inches for the length of the chip. It'll retract and then go about its business from there. Yeah, the chip break option is an awesome option there. I'm going to recompute just to go back to normal here. And Bob brought up the next topic. Does BobCAD have a function so the tool will not dive into the groove and not even see the groove? So yeah, that's exactly what I was going to go over next. If I zoom in, we can see it's diving. Let's go to the rough and finish pass here. As it moves across the groove here, it's dipping down into the groove. And also on the back side, maybe I don't want it to do this as well. Dip down into the back side of it here. I'll right click on the feature, go to edit, and it's on the very first page of the feature here. These checkboxes here, undercut. So I would remove primary undercut right here. If there was an undercut like this on the face, you also have remove secondary undercut as well. But this one is the primary undercut here, and it will remove both of those dips down into those two grooves there. Perfect. All right, so now we'll do the groove operation with the groove tool here, grooving tool. First, I don't like it all cluttered. I don't like seeing all this toolpath and things. I want to see my wireframe. So I'm going to click on the blank button next to the turning job. It'll blank out the stock. It'll blank out all of the toolpath for the rough and finish of the facing and the rough and finish for the OD. If I want to show or hide individual features, I can show or hide them like this. And I can also turn on or turn off the toolpath in simulation and posting of the G-code by clicking on this post button. This is this post yes no option. So this is post no with the controller and the red X next to it. So if I go to simulate or post the G-code, it's only going to generate the G-code of the rough and finish of the facing at the moment, because I've temporarily turned off the turning of the OD. Turn it back on, hit post, it'll generate all the G-code for everything. So you don't have to delete any features you don't want to generate G-code for. You can temporarily turn them off here. And when I hit post, you'll see the G-code for the facing operation, the roughing here that I had with MDI for the test comment. That's added right here before the operation. All right, so covered a lot of ground so far. We'll do the groove operation right here next, and then we'll do the drilling operation in the center here. I like to collapse the items here so that it's not so cluttered here in the cam tree. I like to make it a little bit more simple there. All right, right click on Machine Setup 1 and go to Lathe Groove, the next option down. Select Geometry, and now I'm just selecting these 3 lines of the groove here. Just window selecting them, or you can individually click on them and click OK. Next page, we're turning on the OD again. Next page, we'll do a rough and a finish pass. Next page, we'll output in separate moves. Next page, we have our tool. It's good to show the tool holder here because this is definitely not what we want for the tool holder. So we're going to go to the tool crib, and I'm going to select one of these different tools here. I like to just highlight each one and see what I'm working with, and 1/8 inch should be wide. The groove should be wide enough for this. Let's try it with the OD groove. Click OK. Next page, we have different ways of sorting the passes. So standard pattern, single pass, or zigzag back and forth inside of the groove. And sorting would start from closest to the front face, work our way back. Center, work our way out. Center, work our way out, alternate. So 1, 2, 3, 4, 5. And then we have skip, which this one's kind of weird. I never use this one. I don't really know a use for this one. If someone could let me know in the comments section what they might use this for. But skipping would be starting from the front face to the center, to the end, and then coming back, sort of skipping back and forth like this. I really don't know what that would be used for. I'm usually either using center out or the standard sorting here. All right, next page we have our step over. We'll stick with 50 thou, leave 10 thou, on the sidewalls and the floors for the finish pass to clean up. We also have a pecking option if you want to peck down into the material. Next page, rapids, leads, advanced feed rates, and MDI. Next page is the tool for the finish pass. I want to use the same tool here. So I go to my tool crib and I use this OD Groove tool. Next page, we have a basic finish pass, so starting from the back and just going across like that. We also have forced down cutting, so we could start on one side wall, go towards the center, go on the other side wall, go towards the center, and then you have an overlap option here. Next page, we have 0 for our finish allowance. This is our finish pass, rapids, leads, advanced feed rates, and MDI. And I'll hit compute. Now it's computed, but I don't see any toolpath. It's not blanked out. It's just no toolpath there yet, because if I measure this line here, I go to the top, go to evaluate, go to measure one, and click on the line. The line, or the width, is 1/8 of an inch, so it's not able to fit into this gap here. So I'm going to go back to the tool page, and I'm going to make the tool smaller in this case. Let's go right here. I can just modify the tool on the fly like this from the dropdown and change the tool width. I'm just going to divide it by 2. You can see I can type in a number here, and BobCAD will also do basic calculator functions. If you type in plus, minus, use that divide sign, the backslash, or use an asterisk to multiply, and BobCAD will calculate it for you. And then I hit compute, and here's the toolpath for the lathe grooving operation for now. Looking pretty good, but I'm going to backplot the operation, and I can see it's starting to feed. So the dashed lines are rapid moves, right? So it's going to rapid to this location, but it's feeding from here down into the groove. This is all wasted time feeding down into nothing, because this has already been turned. So I go back to the feature, edit the feature, and on the first page here we have machining from stock, but all this stock has already been turned, so I'm going to change it from geometry. So any geometry that I selected is going to start from that position and work its way down. So now you see that all the solid lines, the feed moves, are removed, and it's only going to feed 100 thou above the actual material that's been turned from here, from the geometry. Do a couple passes and then do our finish pass. Alrighty, so we'll blank out that toolpath. We're back to our wireframe, and we'll do the drilling operation. So we'll right click on machine setup 1. We'll go to lathe hole, the next one down. Select geometry. And what I normally do is I will select this line, and I'm going to select the point furthest back, because I think that picks up the depth right there for me if I want to drill just to that position for this one. Total depth, I think that's 1.774, but I can double check by clicking pick bottom and clicking that point. Let's see if it changes if I click on a different point here. Yep, so now it's almost 4 inches. I'm going to click on the back here, because let's do the drilling operation all the way through the part. So it's going to be 4 inches all the way through the part. Down here at the bottom, I sort of learned recently that there's the option for blind or through. Now blind will drill to the 4-inch position. If I select through, it'll add an extra 50 thou to my total depth in the drilling operations to make sure that it gets past the back surface there. All right, so we'll select through hole. Next page, I'm going to click on lathe hole up at the top. It brings in center drill and drill. I could also add in a chamfer operation, boring, or reaming operations here as well. To do that, I could click on one of my available operations like boring, click add. It adds into my current operations list that I'm utilizing in this feature, which is a group of operations here. I can highlight an operation and sort them by clicking on the up or down arrows here. to sort them in the list of operations, and I can also delete any operations I don't want to use here. So we're back to center drill and drill. Next page, we have posting. I'll leave it as separate moves. We'll get into can cycles probably at the end of the webinar here today. I can set up my center drill, so I can go to my tool crib and select the specific center drill I want to use. I can set my spindle RPM, plunge feed rate. I can set a dwell time for the drilling operations here. Next page, I have my depth for the center drill. I also have a single depth peck or fast peck for all of my drilling operations. We also, I don't know if this is in lathe, but especially in mill for threading, for tapping, I should say. For tapping, we have peck tapping as well for milling. Now that I'm saying it, I'm really wondering if we have it for tapping in here. We do. We've got peck tapping in the lathe as well. So that's pretty cool. So sorry to get off topic there. We'll get back to our position. Now the only thing is when I'm clicking on that point there, I don't know my diameter here that I may want to type in. I'm just going to leave it at 1/4 of an inch for now. Again, we're doing a center drill and a drill. Leave it as separate moves, center drill, parameters. We're just going to do a single depth for the spot drill here, rapids, MDI. Then we've got our tool for the drill, brings in a 1/4 inch drill. I want to double check that, that diameter of the hole. And then let's do pecking. So we'll do, I don't know, let's go a 1/2 inch for every peck. Our first peck and every peck after that. It'll do 9 number of pecks here. And I'll hit compute. Now we'll see the toolpath right here, plunging into the stock like that. I can right click on the drill and backplot it and see the peck every time here at every 1/2 inch. Now I can see the tool and I can see that it's definitely not the right size for the diameter of the hole there. So I'm going to go to evaluate up at the top, go to measure 1, and I'm going to measure this point right here just to see the radius that we're working with. And the radius is 249. Oh, you can't see that. I'm covering it. So you can see under the measure entity box up at the top here, 249 for my X coordinate there. And so I will go back to the cam tree and I'll change that diameter to a 1/2 inch instead. And then make sure that the tool updates. It does update for a 1/2 inch drill there. And I'll hit compute. Now, one other topic for the drilling, we can see under parameters, the effective depth is 4 inches and 50 because of the extra 50 thou for the through hole. And you can see the overall depth is 4 and 200. So it adds an extra 150 thou. What is that for? That is for the tip of the drill. And it's defined as 118-degree drill tip. So based on those parameters, it adds that extra amount right there for you. So the effective depth is 4 and 50, but the overall depth is going to go 4 and 200 in the G code. All right, and we'll compute that. And let's simulate what we have so far. So I'll save our progress here. I recommend saving a little bit more frequently than I am doing here. I've already got this stuff saved, so I'm just saving it as a sort of as a copy, I guess. All right, so we're looking at it from a front face. We're looking at it in length mode. About 276 inches of tool travel for the facing operation here. Then the turning on the OD. Up at the top, we can see every position in X and Z that the tool is at. There's a couple of other really cool options here we could go over as well. what do I like using? Oh, so I'm gonna move myself again here. Back to the top. All right, so down at the bottom here, a couple different tabs that are really useful, I think, in milling and in lathe. Down at the bottom, you have this tab labeled Cut Sim. You can save this piece of stock that we're seeing in simulation. We can save it as an STL file with this Save Stock button. So maybe if I want to 3D print this for whatever reason, or if I want to save it as an STL for my stock remaining and I want to use a different machine, I'm using a different turning job to save it as an STL, that can be really cool to be able to save it as an STL file there. Next option over is this Analysis tab down at the bottom. You can see this drop down that shows. Now the drop down has none. First, it'll show just a basic blue stock for blue color for my stock. Next option, we have tool number. So this yellow is showing what is being machined from this tool number 1. From tool number 2 is green. From tool number 3 is blue for the center drill, but we've drilled it out with this pink color for the tool number 4. And you can double click on each of these colors to change the colors here. And then hit refresh and it'll refresh the colors for you. So you can see exactly what's being turned from what tool, from what operation under operation number. And the next one down, I really like to use this one, this deviation page. It will show us different colors on the stock depending on how much material is remaining. So everything here is in green, showing us everything is cut to size with a cut tolerance of plus or minus 8 thou. And everything except for the back end here, which, this is extra stock right here that we could cut off, and then this is the extra stock right here, of our work piece. You can see there's that extra amount. We'd have to flip it over and do the turning operation on there. But yeah, a lot of great ways to be able to see what we're trying to machine and if everything is cut to size before we run it on the machine and see that the part's oversized still. Eric asked, how about chip breaking in paths for stringy chips? Yeah, I think we went over that. I can go over it again for you, but if you have any questions on it, let me know a little bit more specifically. That would be the chip break option under any of our turning operations here. Under the parameters page, there's a checkbox down at the bottom for chip break. I didn't add that in, but if we want to see it in simulation, I'll make the length of the cut a 1/2 inch. So every 1/2 an inch, it will retract this retract distance of 50 thou. And so when I hit compute, maybe we just want to see it in simulation now. I didn't compute that last time, so we'll take a look at it on this simulation here. Here's the facing operation, and then we'll take a look at the OD turning with the chip break turned on. And this is going really fast, so let me slow it down a little bit so we can see it. So the chip break option you said is, what is that, M65 on the Haas? Let's take a look at what it has for the BC2X lathe. That's going to be a Fanuc-based format. I'm going to turn everything off except for the turning of the OD with that chip break option. Now this is all in separate moves. Let's see what it looks. Oh, I don't think there is an option for can cycles on this. So if I go back to posting can cycles, I think the chip break option is grayed out because of that reason. But let's see if I can get it to go here. So here's the G71 can cycle. I don't know if there's any option in here. I don't see the 1/2 inch here. I see D as 0.05, but I think that's just the retract for every pass. I don't think, yeah, because when I go back to the parameters page, it's grayed out, so there's no chip break option for can cycles. But yeah, let me know if that's what you were thinking there. Go back to separate moves, turn off chip break for now, and then we can take a look at the this is a good segue for can cycles to take a look at. So first, we have our, we're just focusing on the roughing of the OD and the finish pass here for the OD. And under posting, we have it set to separate moves. When I post the G code, you can see the separate moves here, and I can even backplot each position. So this is our tool callout right here, and I'll make the G code a little bit larger that we can see it better. I'm just holding Control and using my scroll wheel to zoom in and zoom out to see this a little bit bigger. So we've got the tool number 1, and then we've got an M40 command, the spindle command here, and then we've got M08, and then we've got G00X6Z 0.05. And this is in diameter mode, but this is showing us in radius because this is the position from Z0X0X3, Z 0.05. And then we're going to X4, and then we're going across with X3.9, and then with our 100 thou depth of cut, or 50 thou depth of cut, technically, and then Z -4, which is where I'm at right here. And then we lift up that back to X4, and then move back across to Z 0.05 from here. So it's going to keep doing that and keep doing that for every step across. Now that's a lot of G code to plot every single point position of my tool every time it moves up, moves down, moves to the left, and moves to the right. Can cycles will allow us to shorten the G code up. Now the roughing and the finish pass in total gives us 269 lines of code. Now, I can shorten that up by using can cycles, and I'll give a brief explanation of what that does here. If I go to posting, change it from separate moves to can cycles, and hit compute. I really don't know if I have to compute it or not because I'm not changing the toolpath again. I could probably just hit finish and then post the G code out again, but it doesn't take too long in turning to recompute toolpaths in milling when we get into more complicated stuff, 3-axis, 4 and 5-axis. It can really take a while to do that, to compute things. So anyways, we've got our G71 command, which is the can cycle for roughing. The P value and the Q value is telling us in line number 10, store this number, and in line number 46, which is at the end, so P is at the start right here, and Q is at the end, which is 46, which is right here, is X value. All right, and what that is doing is it's storing those numbers for our finish pass. It's saying from line number 10 to line number 46, the U value of 20 thou, I believe, is the rapid. What is that? Is that the rapid plane? Or no, that should be the rapids, I believe. And then the W.01 is the depth of cut. So the depth of cut, right? Or no? No, D is the depth of cut, and then F is the feed rate. So at every line of code after this, I don't have to add the depth of cut for every line. I don't have to add the feed rate for every line of code. So really all I'm saying is this is this G code in between line 10 and line 46 is going to be basically the profile of my part here. And I'm going to just sort of plot let's plot the points real quick. So I'll go to, right, because I'm in diameter mode, aren't I? I'll just backplot it, make things easy. So I'll right click on rough and go to backplot. So here I'm at x6 z 0.150. Go down to x4, and then here's my G71 command, and then my next step right here is going to be this one right here, x 1.25, and then z 0.05. Oh, right, I'm not backplotting. I have to plot the points. Okay, so let's go, and I want this to be in radius mode. So before we get into CAN cycles anymore, we'll take a look at the post processor itself. So I want to change it from diameter mode to radius mode very easily. I can do that by right clicking on the post processor over here in the CAM tree. So you can see the machine, and then under it is the post processor with this icon of a controller. I can right click, go to edit, select my BC single line is the post processor. I right click and then go to open. I'm going to open in Notepad, and then I can search for, it's going to be somewhere down at the bottom here of our post processor. This post processor is basically a text file that will format the G code specific to what machine you're using. So you have full control of the post processor here. You can open it in any text editor, or you can have us in the post processor department modify the G code for you, and then we can have you test it on your machine and sort of run it from there. So we've got, we'll plot the points here, and I'll make the points a little bit bigger for us to see. Display, arrows, where are we at here? There we go. Make these points 1/4 inch. There we go, perfect. So these points are giant now. All right, so we're gonna start at our G71 position, and we're going to X 1 1/4. And then we're going to Z 0.05. We're going to Z negative 1.125. X 1.3721. Z negative 1.1271. X 1.4191. Z negative 1.1278. Uh-oh. There we go. Z negative 1.1278. So I've done all that so far. X 1.5556. Z negative 1.134. Z 1.624. Z negative 1.1382. X 1.7436. Z negative 1.1468. We're not seeing a whole lot of difference here, but let's take a look at the cam tree. So that should be a little bit lower, I would imagine. What it should look like here, I'll just so that we can save time, what this should look like is it should be from here to here. There we go. So what I'm plotting the points here. So when I'm plotting the points here, it's going to be basically this G code in the can cycle is going to be plotting the points of the profile, as I mentioned, and it's going to, just for the sake of time, it's giving us a lot of points for this arc. It's going to get to this arc. It's going to come over here, come across. It's going to plot all of these points for us. So it's telling us this is the profile, and just at the machine, it's telling it, okay, this is the profile from the stock that you have. Just do a depth of cut of 50 thou every time until you get to this profile that we created from point to point here. And so it shortens up the G code by a lot. We had 260 lines of code in the separate moves, and we only have 59 lines of code in the can cycle. So if you've got a complicated part that you're trying to do and you want to shorten up the code for your machine, you have your can cycle option there. And then basically what it does in the finish operation right here, you have G71 and in the roughing, and then G70 in the finish, and then it references line 10 through line 46 and says this is the profile of the part, and do a feed rate, do a profile along from point to point there, and do a feed rate of 15 thou. And then your retract moves from there. So a great way, can cycles are a great way to be able to shorten up the G code in Lathe for any older machines. And also, when you get the hang of using can cycles, you can see I'm getting there. When you get the hang of using can cycles, you can just plot the points like this and then be able to see, okay, the profile looks correct. Let's run it from there. You don't have to look at plotting a couple hundred lines of code. You can just plot these, it's about 20 points here, and make sure every point lines up with a corner there, and then you've got your profile from there. And your G code, you can double check your work from there, your G code, pretty easily. Okay, so we'll turn everything back on. We can simulate a second time and post the G code and take a look at everything. And I'll answer any questions that you guys have in the comment section. More than happy to answer anything that we have today. And I want to thank everybody for viewing this live. We have webinars every other Wednesday. Today's October 1st, so the next one will be October 15th, 1 o'clock p.m. Eastern Time. And we'll take a look at the poll, see what you guys want to look at in the next webinar here. So here is the turning on the OD, and then we'll get to the finish pass. Then we'll see the groove operation and then the drilling operation. Just for fun, let's finish off the webinar with the cutoff operation. We can take a look at how a cutoff works and then finish up the webinar today there. So let's get rid of all the points. I don't like how busy it is there. Okay, perfect. So then we have the cutoff. I'm going to right click on machine setup 1. I go to lathe cutoff, select my geometry, and I can select any position here on the back end of the part. I'm just going to click on this point and click OK. Next page, from stock. Next page, cutoff operation. Next page, separate moves. Next page, I'm setting up the geometry for the cutoff operation. Let's go in and select an actual cutoff tool here. Okay, and then our next page, parameters. So cutoff in Z is -4 inches, but you can see the cutoff in X, it's only going down to X 1 inch because of my geometry selection there. So either I can plot a point down at the bottom here, or I can just type in the number here. I usually like typing in the number because then I can give it a little extra here in X to go past the center line of rotation. So just typing in any negative number here, I'm going to go -1/4 inch and hit compute. And then you can see the cutoff tool go down in X to X 1/4 inch, Z -4, X 1/4 inch. You can see the tool holder isn't large enough. It's got a collision there. So I could go back to the tool page and we could actually take a look at modifying the tool holder. So if I double click on the tool, go down to edit tool holder, and we'll make the length of the tool a little bit longer here. That's this one. Let's go 2 inches. And okay. And then we can backplot to make sure that tool looks correct, that there's no collision there. Perfect. All of that has already been turned. So at least we're not hitting that position right there for our cutoff operation. And we'll take a look at it in our simulation. Yeah, let's take a look at simulation. Eric asked, dwell or chip break cuts for cutoff. I'm not sure if we have chip break or a dwell time. Don't use cutoff a whole lot, so we'll take a look at that after our simulation. What I can do is I can pause it. I want to make sure I'm getting right to the cutoff operation. I can hit next op until I get to my cutoff tool right here and hit run. And this is cutting straight on through. Now let's see if we have the under parameters. One thing that I like to show, first of all, we have pecking for the, so sort of like chip break, we have pecking for the cutoff operation. We also have, a lot of customers use this, either a chamfer or a fillet. So first it will do, if I select fillet and type in the radius here, first it will do the, you can see like a little depth right there, then the fillet, and your pass like that. So it just cuts off, the cutoff goes down to here, to this position, comes out, does the fillet, and does the cutoff. What else does it have here? That's it for the parameters. So I don't see a dwell time. I only see a feed rate here under the tool page, but we do have pecking for the cutoff operation. All right, cool. Let me know if you guys have any other questions for today. More than happy to answer anything else on the Lathe webinar today. Show the survey again. If you guys want to click on any of the either of those three options, what would you like to see in the next webinar? October 15th, we have Bob Art Vectorize and Emboss as one option. Option 2, mill 4-axis and 5-axis. And option 3, mill turn with live tooling. And I'll end the poll in 3, 2, 1. I got this last time as well, a 3-way tie. So I don't know if there was 1 vote for each or a couple votes for each, but got Bob saying mill 4 and 5-axis. You know, sort of one other idea here is that we are coming out with BobCAD version 38 in the next couple weeks. So it might be out right when our next webinar is. So we might be going over the new features of version 38. So you'll definitely want to check that one out. There's a lot of cool things in version 38. I've been beta testing it a lot, and a lot of cool features to help you save time in the programming and also simulating and generating code to save time at the machine as well. So hope to see you in the next webinar. That's going to be October 15th, 1 p.m. Eastern Time. And again, thank you all for viewing the live event on Lathe 2-axis. Some basic features here, and also the advanced settings like chip break and what did we just go over? The CAN cycles as well. So thank you again, everyone, for viewing it live, and hope to see you in the next one, October 15th, 1 p.m. Eastern Time. Thanks. Have a great day. See ya.